All right, our next video is on page 53, and this is our other type of operation, but this is a new operation. It's called function composition. And what I want to do is show you that you're actually very much aware of this. So I'm going to use another piece of paper to give you some examples. So if I gave you a function like f of x, and I said it's 4x plus 5, and then I showed you this, hopefully you remember that this means, all right, find your function if x is 3. So I would go over here, I would put 3 in for my x, I'd put it in parentheses, and then I would just clean this up as much as possible. So I'd multiply, and then I could add that 5 and get 17. So my function when x is 3 is 17. So this 3 just went right where that x is, and then I was able to do that. So let's change it up a little bit. What if I said, here's f of x again, and we will still make it worth 4x plus 5, but this time instead of putting a number in there, let's say I want to put in x plus 2 instead. Well, the rules don't change. Where I took that 3 and put it in for x, I'm going to take this x plus 2 and put it in there. So where 3 went in parentheses, now x plus 2 is going to go in parentheses. And then I'm going to do everything I can do to get it cleaned up. So for us, cleaning it up means standard form. So I'm going to distribute. And then I can combine those like terms. And when I'm done, this is the answer. So my function, if I evaluated x plus 2, would give me 4x plus 13. And that's essentially what function composition is. You're going to take something and put it into your function and evaluate it. Except it's going to look more like this than this. So here we go. In addition to the 4 basic operations, we can also combine functions through an operation called composition. The composition of 2 functions is found by plugging one function into the other. And this is how it would look. So when you get all of these parentheses, what I like to do is take the outermost set and really accentuate those. And if you think about it, this f is like this f, and g of x is like 3. Or this f is like this f, and g of x is like the x plus 2. All right? So what this is saying is take, where this said take 3 and put it into the function, and take x plus 2 and put it into the function, this says just take g of x and put it into the function. All right? So what this is saying, let's look at an example. F of x is this, g of x is this, and we're going to start just by easing into it. So I'm going to go to f's function, and this says put 4 into x. So starting this, I'm just going to take 4, put it in parentheses, I'm going to square it, subtract 1. And when we're done, we get 15. So our function, when x is 4, gives us 15. But now what we're going to do, because there's so many parentheses, I'm going to really outline those, is I'm going to take g of x, and what g of x is I'm just going to put it right in there. So f, and then for g of x, is going to go this x minus 3. So now instead of putting 4 into x squared minus 1, I'm going to put x minus 3 into x squared minus 1. I don't think I said that right. So instead of putting 4 into x squared minus 1, I'm going to put x minus 3 into x minus 1. So same thing, I'm going to put it in parentheses. So instead of 4 being squared, it's going to be x minus 3 being squared, and then subtract 1. And now, technically, going back to our earlier chapters, this is vertex form. We're turning it into standard form. Just realize that that squared means there's 2 of those. And then this is what I called the neighbors meet the neighbors. So we're going to have x meet everybody first. I'm going to put this over here, and I'm going to get x squared minus 3x. And then this neighbor is going to go meet everybody, and I'm going to get another negative 3x, and then a positive 9. I'm going to quickly add those up. And now I'm going to take the last thing, bring this 1 along with it. And now I can finish this up by combining those like terms. And when we're done, f of g of x, so f of g of x, that's how you say that. So anytime you see a parentheses, it's f of g of x equals x squared minus 6x plus 8. So we just took 2 functions. One was a quadratic, one was a linear function, and we made a whole new quadratic function. All right, so let's do this first. We're going to find f of g of x. So outlining those outer parentheses, I'm going to take g of x and put it in there. So g of x is 2x cubed. And now this says take 2x cubed and put it right where that x is. And again, anytime you put something in there, put it in parentheses. So there's 3, and then in parentheses is 2x cubed, and then you're going to square that. And just like this squared meant there were 2 of those, this squared means there's 2 of these as well. And I can multiply my numbers. 3 times 2 times 2, that's 12. And x cubed, that's 3 x's multiplying, 3 more x's multiplying, so that's a total of 6 x's multiplying. And now we have found f of g of x. Now this says, all right, now that you have f of g of x, take -1 and put it into your new function. So that's all I have to do here is go here, 12, again I'm substituting a number in, put it in parentheses. I would do my exponents first, -1 to the 6th power, so -1 multiplied 6 times is 1, and then take 12 times 1 and you get 12. So this one, to get f of g of -1, my answer would be 12. I'm missing a set of parentheses. All right, let's try another one. So we're going to find a new function. We're going to call it k of x at this time, and this is a composition function. So this says, outlining those parentheses, that f of x will be going into g of x. So in my parentheses, I'm going to put f of x, which is worth 4x cubed. And now this says go to g's function, and wherever there's an x, put your 4x cubed. So in parentheses, 4x cubed, that will be squared. And then over here will be 4x, put it in parentheses. Again, the square just means there's 2 of those. So that becomes 16. x3 and x3 is x to the 6th. Here's the other part, just dropping down. And then that's it. These are not like terms. Remember, adding, subtracting, super picky, so that's what we get. So k of x is now this. And then last problem, just a reminder, it's a little different than multiplying, so f of x times g of x. So here's f of x times g of x. This is a simple neighbors meets the neighbors problem, and I'm going to get 4x to the 5th plus 4x to the 4th. And then I cannot combine those because they're not like terms, so this is what h of x is going to equal. And so you're going to have a little bit of practice. There will be a video to get you started on that, and also on the other part, the first part of the video for 2.6.